Hi everyone, it's Natasha from the Nextwork team, and today we are going live for a new MCP and data engineering project and series, actually, because we are launching a brand new series today. This one's project number 1, and it's gonna be so exciting. Let's just jump into the project, actually. I've got it open right now, and the link to that is also in the chat. If I just add it in right now. There you go, it's in the chat now. And it's also in the video's description. Open up the project. The best way to learn and to explore new things like MCPs or data engineering is to build. So let's get building together and let's discover the PostgreSQL MCP and what we've got in the next 3 projects of the series. Wow, we've already got Deuce here at... Whoa, hola Natasha. Hola Deuce, it's so good to see you. Oh my goodness, and Karthik is here. Hi Natasha, hello. Yeah, I'm really excited to do another MCP project. The last one was great. I think everyone learned lots from it, and this one is another step up. So you might notice that we've got 4 parts today. So there's part 1, you're here. We've got part 2, which is an MCP on dbt, part 3 on Jupyter, and part 4 on Grafana. Now you're not expected to already know what these tools mean or what they do. That's what this series is for. But the series theme is on the world of AI, MCPs, and data engineering. So if you've used MCPs before, you might be familiar with the fact that you can, connect AI clients. In this case, Cursor, which is the AI client that we've been using throughout our Nextwork projects. You can connect that to an MCP that allows LLMs to actually, let's say, make API calls or do commands in external tools. Because whenever you're working with an AI LLM or an AI agent, let's say, in Cursor, you can use AI to chat with your code, for example. But let's say you actually want to ask Cursor, hey Cursor, can you send an email for me? And Cursor goes, first, how do I send an email? What email do you use? Do you use Gmail? How would Cursor even authenticate to your email to send that? How would Cursor even authenticate to your inbox to send that email? There's so many things that, as good as AI LLMs, as capable as they are, they're also limited a lot when it comes to authentication and when it comes to very app-specific tools and functions. So because of that, MCPs came into the world of AI, and they pretty much let AI LLMs or AI tools like Cursor have the ability to actually talk to your external apps. So now with the PostgreSQL MCP, Cursor can now actually talk directly to Postgres and do things like create a database. If you've got an MCP for GitHub, imagine now Cursor can actually log into your GitHub account and create things like pull requests or repositories, or it can even pull data from your repositories for you. So that's a quick refresher on MCPs. Think of it as just a bridge that allows communication between external tools and your AI LLM, your AI agent. We've got some lovely comments here already. Karthik also says, long time no see. Back to you, Karthik. Long time no see indeed. We've got Pingo Pango. What a cute name. Saying hi. And Deuce says, I'm very excited about the new project. Same here, Deuce. Let's get started. Oh, but we also have Amar Zaya asking, can I ask a question? Of course, that's exactly what the chat is for. All right. Now, in this project, have you ever wondered how companies like Instagram, Spotify, and Apple manage their databases? What database technology are they all using? Do you want to try it for yourself? So in this project, you'll be creating your own database using a database technology called PostgreSQL. It is the same technology that 500K companies use to build and manage their databases. Honestly, I bet that this number could be even higher. But if you're thinking, wait, what are databases? You can always hover over keywords like this and get the definition straight away. So databases are organized collections of data. They are, Oh, I love this little analogy. They're like digital filing cabinets that let you store, manage, and retrieve information efficiently. So when you think about Instagram, what's their database for? Probably to store what are posts, likes, comments, users, passwords. And if we were to hover over PostgreSQL, here's our first taste of what it does. PostgreSQL is a powerful open source relational database system. It's known for its reliability, feature robustness, and performance. Honestly, let's just pause here at powerful and open source, because I feel like those are the two key things about PostgreSQL that makes it so popular. The fact that it's open source means that it is, always updating. It is also not gated behind like some big price tag for you to use. And powerful is very, very true. PostgreSQL is known to be one that a lot of production-ready databases will use, whereas something like MySQL is more likely for like smaller databases, although a lot of companies can still use MySQL. PostgreSQL is just known for having a lot of features. You can manipulate your databases in many ways, and it can just store huge amounts of data. So here's a little preview as well of the database that we're about to create together today. Here are some tables that represent data for an e-commerce site. So we're going to be loading like 40,000 rows of data, but of course, because PostgreSQL is so, I would say, so powerful, it's not like it's going to take a long time. In fact, it's going to take like a few seconds. All right. So in this project, let's get ready to connect Cursor to Docker and PostgreSQL MCPs. We're going to prompt Cursor to create a Docker container with a PostgreSQL database. We'll load that 40,000 rows of data into the database and then query and visualize your database. Now, something to probably mention is if you're wondering, oh my gosh, like I don't have experience with Docker or Postgres, am I going to be okay? Just know that there is no experience required for this project. In fact, because we're using MCPs, we're going to be doing a lot of these things through natural language prompts. So there's no pressure to like learn all these commands because you can just give simple commands or prompts to Cursor, and you can expect Cursor to actually use MCPs to do those functions for you. That's exactly why MCPs play such a big role in this entire series. All right. You can even check if this project matches your goals. If you like to just click here, we're just going to pop open a chat that you can use to understand whether or not this project is right for you based on your skill level and your goals. Awesome. So we're about to get started with the project itself, but I am noticing that we've got Amazea's question. Great question about obtaining certifications and whether it helps you in your ability to get a job. Does having the certificates in portfolio give me an advantage over other applicants? Yeah, these are great questions, and actually I highly recommend that you join the Nextweek community where there are lots of learners also thinking about the same things and going through a very similar journey as you, probably learning new things, figuring out what is your path to a new career, and also what are your next steps, to get closer and closer towards maybe a life change, maybe a career switch, anything that fits your goals. So back to this thing, yes, certifications can make a difference in your ability to get a job, but it's, the question is, by how much and whether or not it is the best, investment of the amount of time that we have. Certifications cost money. They can take a lot of time for you to study and to take the exam. Whereas the great thing about building a portfolio is that it's always in your own time, and it's always something that you can continuously improve on, whereas a certification is like a static, kind of like, hey, at this point in time, 19th of November, 2025, you have passed this. Whereas a portfolio is something that is constantly building, always evolving, and it is where you start to build and actually apply all of those skills. In the real world, when you're working, we're not really assessed on how well we can do our jobs based on how well we can answer multi-choice questions. And that's the reason why portfolios and building and doing projects give you such an edge over other applicants. What a great signal to show to an employer that you can actually do the day-to-day job. So highly recommend that if you've got, let's say, 100% of your time is, you've got like 100% of time that you can allocate, personal recommendation is to actually spend at least 80% of that time on building, and then maybe 20% of that time on learning concepts and scaling up on things outside of the time you spend on building. It doesn't have to be spent on certificates, but actually just having a good theoretical understanding of things and exploring the news, exploring maybe what's something you don't know yet is always beneficial, so that you're always learning too. All right, Armazea, thank you so much for the question, and we'll just move on. All right, so because we are doing some guidance today, you might expect that my guidance style is a lot faster. But if you're wanting step-by-step guidance for this project, you can always click on step-by-step guidance for the project guide, or check out our dedicated step-by-step guidance live, which is also in our YouTube channel in the live stream tab. Cool. All right. Inception moment. I always love this moment when you just look at your own thumbnail. If I click on it, we're going to watch the stream ourselves. Spooky. All right. So before we start step one, what are we doing in this project? Great question. So in this project, we're going to use Cursor. Oh, actually, let's just say what we're going to create. We're going to build a Postgres database using Cursor and the PostgreSQL and Docker MCPs. Now, do you remember what Postgres is? All good if you're wanting a bit of a refresher. Here is a simple explanation of why are we using Postgres and how does it help us create our database. Let's see. Oh wow, it's almost like it's read our minds. So Postgres is a powerful and widely adopted open source relational database system trusted by many companies for managing their data. And let's also understand Docker as well, which is going to be our next question. So Postgres is a powerful and widely adopted open source relational database system. I would say just use database system, trusted by many companies for managing their data. While Docker is a crucial tool for setting up your database environment. It helps you create your database by providing a way to run PostgreSQL in an isolated and easily manageable environment called a container. So that is completely true too. So actually, we'll just do this. Docker is, and I love that you can just highlight like this. So cool. Man, I love these definitions. Well, this is very, very handy for us to answer this question, isn't it? So Docker is a platform that packages applications and their dependencies into isolated units called containers. So in this project, we use Docker to run PostgreSQL in an isolated and easily manageable environment. Manageable environment. I'm quite happy with that. So let's select done, and let's quiz ourselves and see what we might already know before we even do the project. So what's the main function of MCP in this project? Is it A, to replace Cursor's chat interface? Is it B, to directly install Docker Desktop? Is it C, to manage operating system updates? Or D, to allow Cursor to interact with external tools like Docker and PostgreSQL? Well, you might remember that MCPs, their job is to be the bridge between AI agents or LLMs and external tools and apps. So this one is a great response to that question. What file is used to configure MCP servers in Cursor? That's a hard question if you haven't done the project yet. So it's either settings.json, have a guess, pyproject.txt, .toml? Is it dockercompose.yaml? Or is it mcp.json? So for this one, I think the mcp.json is a good giveaway. I mean, the name of that file, MCP, like, come on. And next up, what is the purpose of UV in this project? Is it A, to download Docker Desktop, B, to manage Docker containers, C, to configure PostgreSQL uses, or D, to run MCP servers? What do we use UV for? What do you think? Close your eyes. Should I close my eyes and randomly pick one? What do you think? What if I picked B, to manage Docker containers? Do we know what UV is actually? We'll definitely learn a lot more about UV in this project, but it is a Python package manager, as a hint. So what happens if we pick B? Maybe not. Docker Desktop manages containers, not UV. But yes, UV is used to run the MCP servers, providing the necessary Python environment. So for us to actually use those MCP servers, so MCP is a protocol, MCP servers are the actual, like PostgreSQL's MCP, Docker MCP. Those servers are the actual MCPs for those individual apps. And they need a Python environment to run. And that's why we use UV in this project. What is the primary purpose of using Docker in this project? Are we editing SQL, SQL queries? Are we trying to run PostgreSQL in an isolated environment using Docker? Or to manage your cursor settings using Docker? Or are we using Docker to manage our Python packages? Oh man, well, I did give a little hint on what we used UV for and what UV does. It's a Python package manager. So it'd be interesting if Docker was doing the same thing. Nah, cross that out. Well, the answer is B. We use this because Docker provides a containerized environment for PostgreSQL, which basically means it's a lot easier for us to run PostgreSQL and create that database because we're using Docker. Very nice. And what is a prereq for running Docker Desktop on Windows? So to run Docker Desktop on Windows, what do you need? This one's a tricky one. I mean, what if you're not using Windows? I'm on a Mac, please. But a big shout out to all of our Windows users. Pretty sure it's going to be WSL. There you go. So Docker Desktop on Windows requires WSL2 so that it can run Linux containers. All right. We've got 4 out of 5 correct. Let's go ahead and set up our environment in step 1. Let's do it. Okay, so let's get the environment ready. We're going to install Docker Desktop for running containers, and then we're also going to install UV for managing Python packages. So by the end of the step, we're just going to have our environment ready for us to be able to install and run the MCPs. All right. We're going to create a project folder for the series. Checks out. We're going to install Docker Desktop, install UV, and make sure that both installations are working. That's cool. It's really part of the Network spirit, that, when you want to install something, let's always try to verify that as we go in every single step that we've done that step correctly. If you've installed something, let's make sure you've installed it correctly, because later down the line, when you run into an error, it really helps to have known that, okay, but I have checked all of these steps along the way. So if I'm still running into an error, maybe something went wrong here. It's a lot easier for you to pinpoint exactly where the error has come from if you've been verifying, all of your steps. All right. So in this step, we're setting up our development environment by installing Docker Desktop and UV. Docker Desktop will help me run PostgreSQL in an isolated and containerized environment, aka it makes it easier. It makes creating our own PostgreSQL database. Way easier. UV is a Python package manager, which will be responsible for creating a Python environment to run our MCP servers. It's a bit complicated, isn't it, sometimes, like the dependencies that we've got and why we need them. But to summarize, really, we're installing Docker because we need it to actually run PostgreSQL, and we are also installing UV because we need that to run our MCP servers, to be more accurate. All right, let's just check if we've already got Docker Desktop installed by running the Docker version command. All right, I've got my terminal open here. So shall we just run docker -- version? And it's command not found for me because I don't have Docker. We're gonna have to download Docker Desktop here if you don't have Docker. And if you're on Windows, just check if you've got WSL2 installed as well. Okay, so I'm gonna open a new tab. Hello? Are you opening in a new tab? Maybe not. That's interesting. Why are we opening in a new tab, friend? Oh, my tab is being funky, isn't it? Why are you being funky today? I guess that's okay. And make sure you double check which version of Docker Desktop you should be installing. For Mac, you should be clicking on the Apple button, clicking About This Mac, and checking if you've got an Apple chip or an Intel chip, because that determines which one you pick here. And for Windows, the instructions for that are also in our High Touch guide if you like a bit more help. Yeah? Okay. Is this live? Says moi. Great name. And it is absolutely alive. Not a rerun, actually. Not a rerun. And Dee says maybe my browser died. Totally possible. Yeah, it's always strange when something that you always do every single day, you know, opening things in a new tab just stops working. Yes, but we are downloading Docker Desktop right now. Let's have a look at our progress. Okay, it's gonna take 3 more minutes, which is a little bit of time, but I think that buys us time to look at the next few steps coming up. So we've got our Docker Desktop dashboard that we need to open, and then we need to wait for Docker to fully start. We need to spot a whale icon in our menu bar to make sure that's installed properly. Okay, cool, that makes sense. And then we've got something on why do we use Docker containers? We are using a Docker container too. This is important because, and Du says, I already installed Docker. Everything is fine on Windows for me. Oh, great. Are you following the project guide by any chance? You might have a good preview of what's coming up next then after you've installed Docker. Subham says hello, saying hello to you back. Thanks so much for joining. Great to see you here, man. All right, well, this question is slightly similar to what we've already answered before, isn't it? Before we've said, Docker Desktop will help me run PostgreSQL in an isolated and containerized environment, aka it makes creating our own PostgreSQL database way easier. Maybe there's something more that we can share to make this response a bit more unique too. So let's say we can actually challenge ourselves and say, what is a Docker container? And what is a Docker container? Why do we use it in this project? Do you think you could do this project without Docker containers? Those are some great questions to ask. And we've got some questions here We've got a question about if this is live, can I ask questions? Absolutely. Yes, it is. It is live, so you can definitely ask questions. Sabam says for Mac, what should I do? Yeah, I mean, I'm actually on Mac right now myself, and all I've done so far is I've visited the Docker Desktop website, hovered over download Docker Desktop, and then selected the one that suits my chip. Don't forget that you can always check out the detailed project guide also in this link here. I've just put it in the chat for us. Thanks so much, Shubham. All right, it's still installing, by the way, Docker Desktop. I think it's going to be another minute away. So in the meantime, let's try to use this. We are using a Docker container. Ooh. Okay, great. Okay, nice. We are using a Docker container Cool. So we are using a Docker container to package, maybe, to run a packaged version of PostgreSQL, and all its dependencies into a standardized unit. This means PostgreSQL. Ooh, it's not spelled correctly, is it? Runs in an isolated environment, making it simpler to set up and manage. This is important because without Docker containers, without running a containerized, without running PostgreSQL in a container, we'd be spending much more time just on setup and making sure our environment is fit for running PostgreSQL. There you go. So I would say we could even ask for confirmation. Will we be spending more time on environment setup if we weren't using a containerized PostgreSQL environment? Okay, and we've got a great question too. Oh my goodness, has some great questions. This one says, my question is, what's the difference between MCP and a LangChain workflow that calls an API? Wow, that's a great question. Why don't we actually put it right here? Because I have to be honest, I actually don't know the difference between that and a LangChain workflow that calls an API. So why don't we give challenge, ask a go. Oh, and by the way, great to get some confirmation that the containerized PostgreSQL environment saves us a lot of time on environment setup too. All right, but let's create a new chat just to ask this new question. Let's break them down. Ooh, are you excited? Let's see. All right. And I think it's given us a pretty decent one, so we might need to expand this a little bit. All right, so key differences. MCPs are specifically designed to enable AI coding assistants to understand and operate within a developer's local environment and interact with development tools. It's about making the AI a smart and context-aware coding partner, whereas a LangChain workflow is a more general framework for building LLM-powered applications that can integrate with external services through APIs. It's about extending the capabilities of an LLM by giving it access to external information and actions. So I would think MCP is about deeply integrating an AI into your coding workflow, making it aware of your project's intricacies, whereas LangChain is a toolkit for building applications where an LLM can intelligently use external services to achieve a goal. It feels like they actually achieve very similar things, actually. So you've asked a question that is extremely valuable. It almost feels like they achieve similar things, but for different, they achieve a similar outcome, which is connecting like AI or LLM with an external tool, but maybe in a slightly different way and for a different purpose. Where MCP is focused on a developer's workspace, whereas LangChain and calling APIs can be used for a much broader range of applications. Yeah, that is very interesting. It is true that whenever I come across an MCP, usually the instructions are about how you can integrate this into Cursor or VS Code or Cloud Code or Cloud Desktop. And it's less about how you can integrate this with your own AI agent or LLM or your own app. Maybe that's the reason why, like, the purpose is just built for a different purpose. So thanks so much for the question, and you've really got us thinking. All right, in the meantime, I've seen that Docker Desktop's installed now, so let's go and open it up and get Docker running. My goodness. Let's put it in here. Cool. You might notice that you can actually drag and drop Docker into your applications folder. And I think it is now copying Docker to my applications folder. Awesome. Again, if you're wanting Windows-specific instructions, we actually go into a lot of detail in our high-touch guide, so I'd recommend checking that one out. But now that I've installed it, I'm going to go ahead and open up Docker Desktop. All right, anticipation. Cool, let's open it up. All right, and we've got a Docker subscription agreement that just opened up. Whew. All right, accept that. And we've got finish setting up Docker Desktop. Finish. Use the recommended settings. We'll be okay. We don't need any special setup for Docker itself. The focus is actually on creating a PostgreSQL database. So quite happy with just using the recommended settings. And if it asks you to create an account, did you know you can just click skip? Because we don't actually need it. How good. So we've already got Docker Desktop set up. And a big thank you to is that actually the right way to say it? You have to correct me if not. For saying, oh, you're really, really great at taking questions. Thank you so much for not vomiting words and actually taking time to explore and answer. Well, it's teamwork here. You've asked a great question. So sending all the gratefulness back. Thank you very much. Okay. So I think that our next task is to actually take a screenshot of Docker Desktop running. What great validation that we've got that first bit of setup done, and we'll just upload that screenshot here. And another great way to verify that Docker Desktop is actually running is by checking whether or not you've got the whale icon in your taskbar or in your menu bar. If it's running, then you know Docker's working. So we've submitted both our validations now. I think we can hit done, and the task is all completed. Okay. Because we are doing some guidance instead of step-by-step guidance, we have sneakily taken it out of the instructions. But since you're a special one and you're watching the live, here's the tip. Don't forget to always verify and check what you've done. Have we actually installed Docker? Let's run docker -- version again. And there we go. Now a completely different result for the same command. Did you see that? Now a completely different result for the same command, because now we've actually got Docker downloaded, Docker Desktop downloaded, and it's also running here. Well done, team. So next up is we need to double check that we've got Python now. So Python is going to be needed again so that we can run UV, and also so that one of the MCP servers, the PostgreSQL one, definitely needs Python 3.12 or more. So anything, even if it's after 3.12, like 3.13 or 14, you'll be able to run the PostgreSQL MCP server later. So let's select what is Python 3 version, and let's just check whether we've got that one. All right, so my version is actually 3.12 or more. So as you might see, it's 3.14. So it's in the safe range. We can keep on going. If you're using Windows, by the way, you're checking for your Python version. Yeah, not Python 3, but Python version. So just make sure you're running the right commands. We usually have screenshots for you to just make sure you're seeing the right thing. Okay. Now, Subham is saying, I can't even hit the skip button. It's going to Google Accounts. Damn, are we going to Google Accounts right now? What is that for? Does that mean you can't even skip the account setup in Docker? If that's the case, it is possible, like, for you to create an account and head back into Docker. Interestingly enough, I've never run into the issue of not being able to hit the skip button. You might find that it's helpful if you quit Docker Desktop and open it again to try hit skip. But if that still doesn't work, I promise you, I have created a Docker account before and it didn't take too long. If you're open to it, I'd recommend creating the account. If you still can't click skip, you've got this. Keep us updated on how you go. All right. Now, if you see an older version of Python, we've even got the instructions on how you can upgrade it so that you are at the latest versions. In our case, again, because I've got 3.14, for example, we can move on. Okay, so it's compatible with MCP servers. We can go ahead and now set up Cursor. If you don't have Cursor, you can download it right here, or check out our dedicated project on how to set up the Cursor IDE. Now, because I've got it downloaded, it's right here ready for us. So we're gonna create a new window. Here you go, we've got Cursor right here. And since we've got Cursor, it's time to set up a dedicated folder for the project. All right, from this point forwards, all commands will be run inside Cursor's integrated terminal. There is a terminal UI with Cursor. Here you go. You can even show it right now by pressing Command J or Control J on your keyboard. There you go. There's a terminal UI, so you don't need to switch between apps so that you can run terminal commands. You can even run docker -- version here to just double check that it can actually run commands like you did in your dedicated terminal. Okay, well, what we're going to do now is we're going to open a new project and create a dedicated folder for this entire series called MCP Data Series. All right, so our project folder, let's put it in desktop, and let's call it MCP Data Series. Create it, open, nice. Here we go. So here's our dedicated workspace for this series. and we're now going to install UV, which is that package manager that we were talking about. Now, UV is a tool that installs and manages Python software, and we need it to actually install our MCP servers. We also will need it to create that Python environment so we can run the MCP servers whenever we need them. So what that tells us is although you know how we've said that MCPs are like the bridge between Cursor and the external tool, the server that actually sets up that connection is something we actually need to install so that we can run it. So you might be wondering, and I am right now, why do we need to install our MCP servers? Why is it something that we install? Interesting, isn't it? So did you see that? Whoa, 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 whoa. It's using the same words as me. Act as a bridge, allowing Cursor to connect with and control external tools and services. No way. How are we using the same analogy? My goodness, are you listening to this live right now? Can't we connect to remote MCP servers? What's the difference between installing MCP servers and just using a remote one? Let's do it. So here's our response. For this project, installing the servers locally is key because it allows Cursor to directly interact with and control Docker and PostgreSQL running right on your machine. That's true. So Docker and the containers are running in our local machine. PostgreSQL, that database, is going to be running locally on our machine. They're not running, in the cloud. So because of that, the communication tool needs to be able to actually connect with what's local in our local environment too. So when you install them locally, Cursor gets direct access to your local environment. I just love it. I love it when there's a genuine reason for things like why are we installing the MCP server. Using remote MCP servers, which are servers that you don't need to install, would typically involve connecting to resources that are in the cloud. So for the purpose of this project, all of these resources, the Docker containers, the databases, they live locally, and therefore our MCP server should too. Okay, so UV is the package manager that is going to be the tool that helps us install those MCP servers. And check if you already have UV installed. Let's check. And don't forget, you can use your local terminal now, so you can press Command J to show it if it's hidden. Or you can also use your menu bar, terminal, new terminal, like that. All right, we've got UV installed. So I've got UV 0.9.9, that looks great. If you don't have UV installed, here are all the steps to get it running. It's actually a very, very simple command. I can even just run that command right now. Even if you've got it installed, why don't we, I should use the copy button, shouldn't I? Why don't we just run it anyway? Oh, hey. Just to show that you can install UV like this. There you go, just like that, you've installed UV. Same with Windows, very, very simple command. And you can even explore how the command works as well. All right. If you're running into errors, you can always troubleshoot with us. You can ask over here a few questions. You can even add screenshots. Okay. So, of course, let's not forget that we will need to check that our UV installation worked. So we're going to go ahead and check uv -- version. Here we go. I went from 0.9.9 to the latest version by running that install command again. Nice. Okay, so the dependencies we set up in our local environment in this step, they include Docker, Docker Desktop, Python, and UV, because we need Docker to run containers, Python to run our MCP servers, and we also need UV. I would say Python 3.12 specifically. And UV, we need that to actually install the MCP servers themselves. Running -- version for each dependency shows us a version number for each. Which confirms that we've got them installed and ready for action. Hey, very nice. Let's hit done. Nice work. Woohoo! You now have Docker and UV installed and verified. Nice job. Docker will run PostgreSQL in a container. UV will install the MCP servers, and Cursor will use those MCPs to control Docker and PostgreSQL through chat. So good. You're going to see how natural language prompts is going to turn into action, like real action in all of these tools. So let's set that up now. We've also got a lovely question in the chat. Rohit says, can we all practice together, guys? Isn't that cool? Are you in the NextWork community, or would you like an invite into the community? We always have lives going where you can do all of these projects with someone else in the moment as well. We've got Dio saying, I didn't know about UV, but I find it very interesting. Oh, cool. I will need to see it in action to see what it really does. Oh, cool. If you know pip, UV is also just like a faster version of pip. Pip is also a Python package manager, and it's like the default one that usually just comes with installing Python itself. All right, so now we're on to step 2, which is to connect Cursor to Docker with an MCP. We'll set up MCP servers that bridge Cursor to Docker and PostgreSQL. Okay. How are you feeling, everyone? Ready to go for step 2? All right. Now, we've got a lovely reminder here. If you need a refresher, MCP is a standard that lets AI models connect to external tools and services. Unlike regular Cursor chat, which can only read and edit files, once you've got MCP servers connected to Cursor, Cursor can actually create and control containers. It can actually execute SQL or SQL queries on databases. It can do things way beyond just editing your code files or analyzing what's in your code base. And that's the reason why we're using MCPs too. Now, to actually set up MCPs, MCPs don't come already pre-configured when you install Cursor, so you're going to need to configure it yourself. We're going to initialize a Python project with UV, hint, that's why we created that project folder. We're going to need to configure Cursor to use both those servers, and then restart Cursor so that we can activate the MCPs and wake them up so they're actually working. Okay, so let's get ready to do all 3. All right. In this step, we're going to install MCP servers, which are programs that connect LLMs with external tools and services like Git, let's say. You can even connect it with, what's another MCP that we used? We've used Supabase MCP before. Do you know there are also some cool ones? There's like an Airbnb MCP. Get Airbnb. You know, if you use task management tools, a lot of them have MCPs too. I think there's even one for weather. Like there's like a weather MCP, and there's even a time MCP. Anything that can basically power up your coding assistant. Okay, and of course Postgres and Docker. Without MCPs, Cursor can only interact with our code base. With MCPs, Cursor can now I would say I really like the wording here. Control real infrastructure and services. You can now control real infrastructure and services, which we can prompt via a Cursor chat. All right. So let's initialize a Python project. Servers need a Python environment to run, and that's what UV is going to be doing for us. We're going to initialize a new UV project using the command UV init. So let's head back into your terminal. You can quit your terminal app now, by the way, and you can just use Cursor's terminal to run UV init. Now, don't forget, that's very bad typing skills for me. Don't forget to actually run pwd, for example, to just make sure that you are in the correct directory. In this case, let's now run UV init. So we're initializing that Python environment. Oh, my typing skills are terrible today. Cover your eyes, everyone. My goodness. Okay. So adding MCP data series as a member of the workspace. Great, I think we've got that initialized. We've initialized the project now. All right, so what does UV init do? This command creates a Python project structure with several files, including pyproject.toml. That file tracks dependencies in your project. There's gitignore, and that helps you exclude files from Git. There's a README file, there's even a main Python file. Honestly, if this is getting a little bit complicated, don't you worry. We've always got ask to help us. So you can actually ask, for example, why do we need a Python environment to run MCP servers? Do you have any other questions? Add them to the chat if you do. My question is, how does UV create the Python environment? Oh, great question from Subhan. Is UV a kind of framework? Great question. Well, so far, UV has been defined as a Python package manager, which is a tool that helps us install other Python tools. But let's address whether or not it's a framework. Well, UV is not a framework. Again, it's a Python package manager. So a package manager means that it helps us automate the process of installing, upgrading, and configuring and removing these software packages. I would say, let's say here. All right. So if we say Python is a package manager, it helps us with automating the installation of packages. How did it just create a Python environment? Okay, so first, let's understand what is a Python environment. A Python environment is an isolated space on your computer where you can install specific versions of Python and its libraries without affecting other projects. It keeps your project dependencies separate and manageable. Yeah, that's why we love Python environments. It's really just like a I would say a place that a space in your computer that you've put aside just for you to install all these different kinds of dependencies so it doesn't mess up, any kind of dependencies or work that you're doing in other parts or like in other folders in your computer. Because environments are isolated, it also just makes sure that if you want to delete your environment, you're deleting all of those different kinds of dependencies with it without needing to be like, oh my god, what did I install in here? I need to make sure to uninstall it. You can just delete your environment itself. Cool. Because MCP servers are written in Python, they do need a Python environment to be executed. So it's a great idea to also initialize a Python environment to make sure that your MCP services have all they need to actually work too. Although it's not always like a requirement, in our case, we want to make sure that we've got one. Oh, when I say it's not always a requirement, it means, your computer might already be capable of running like Python, but creating this dedicated Python environment is a very surefire way of making sure that your servers can actually run. Very cool. So the environment itself, like these files basically make up the environment itself. UV is designed to handle the setup of these Python environments, making it much faster and simpler than traditional methods. Okay, very cool. That was a nice little detour to really understand what we're doing by running UV init. And if you wonder what's going on when we see something as a member of a workspace, it just means that there was already an existing Python environment, and it's totally fine to have one. Cool. So what did UV init create, and why do we need a Python project? The command UV init set up a Python project because MCP servers need a Python environment in order to run. The files created include pyproject.toml, which stores the project's dependencies, getignore, which is useful for making sure sensitive data isn't saved in a public or cloud-based, especially a cloud-based, Git repository. README for documenting, for storing documentation about our project. And main.py for running Python scripts. Awesome. A heads up, we won't be needing to really understand all of these files to do this project, but it's always good to understand what's going on, because if you check out your file explorer, look, these are the files that were created, just like what's mentioned in the project guide. Okay, so here comes the magic. We're now going to tell Cursor about our MCP servers. We're going to add them to our Cursor configuration file so that it can actually connect with Docker and Postgres. Otherwise, how does Cursor actually know, that we've got Docker Desktop installed, that we've got that we want to create like a PostgreSQL database? We really need to make sure that it has all the tools it needs. Like, let's set up the bridges so that it can call these tools later on. Okay. Let's go ahead and open up our settings, which you can find here. And you can always hide away these other panels by actually just clicking on these other buttons here. There you go, hidden away. And let's go ahead and select Tools and MCP to add those MCP servers. Now, you can just click copy and just paste them straight away like this. And don't forget to save your file. Save it, check your Cursor settings page again, and look at that. The installed MCP servers are already showing up here. We've got the Docker MCP. We've also got the Postgres MCP. Nice. It does take a little bit of time. And to make sure those settings are now loaded, you typically will have to actually quit cursor and reopen it. Okay, let's go ahead and reopen that right now. Okay, there we go. If it's asking to access data from other apps, I wonder what happens if we click don't allow. I guess we can always change that setting later on, can't we? Okay, and let's just check our settings one more time. Tools and MCP. All right, it's loading. It's loading. It's loading. It's loading. Okay, no worries. Let's let it load. I'm gonna try not be impatient. In the meantime, you can also dig into how a configuration file for MCP works. So here you might notice, it's working, so good. Here you might notice that when we clicked on adding an MCP server, it was actually a JSON file that got opened up. So this JSON file is literally your MCP configuration file. And for every single MCP server you want to add, there's typically 3 things that you're going to need to define. One is there is a command for that MCP. So look at how it was in the MCP servers that we've just set up. This command is the program to execute the server, which means to actually run the server. We use UV to run Python packages in that command. There's args, which is the argument passed to the command. It tells UV which MCP package to run. So basically, oh, actually, I'll show you. And then there's environment, which are the environment variables like connection strings, socket paths, API key. Those are all like environment variables you could pass. But you know, literally, it's basically saying, let's run the Docker MCP by running this command. Ooh. Like uv run -- with Docker MCP. Docker MCP twice, interesting. And then access mode is equal to unrestricted. You know, that's basically what these variables are trying to say. And then the environment basically means when we run this command, we also need to pass this environment variable that the Docker host that we're wanting to use is a local one. Okay. So I hope that gives you a little bit of like context and detail around how this JSON file actually works. Okay, very cool. So our MCP servers are working. Do you see that green light? That tells us that it's working. If you see a red light, it does mean it's not working. Okay, and it's totally fine if it's not working. It usually means check. Okay, do you have Python 3.12 or more, or even later, 3.12 or later? Do you have, are you sure that you've used the correct code or like the correct JSON configuration? Don't forget, you know, if you're using Windows, switch to the Windows tab. This Docker host looks a little different for Windows. Do you have UV running? Is UV version returning a version number? Do you want to try to reinstall UV maybe to help you make sure that you've got a current version of UV that's not outdated? Okay, so those are some things that you can investigate if it's not working for you. My mind was blown when it turned out that it worked. I thought it wouldn't show me the tools for those MCPs, but against all odds, it worked. Isn't it crazy? Yeah, if you expose that, expand that, you can actually see all of the commands or all the tools you now have access to. Yes, Deuce has a great point here. Deuce has also tried to run the commands The Docker command works fine, but the Postgres one gives an error. I assume this is because there's no database or the URL is not correct yet. That's right, very good. So it says here that our Postgres setup says we're using something in port 5432, but is there anything in port 5432 right now? That's something that we'll be setting up in the next step. Subam says, I have a doubt. Oh yes, we've talked about this. Is it similar to Node.js? Is UV similar to Node.js? Oh, that's another good question. Let's cheekily ask a question. Is UV similar to Node.js? I wonder what's gonna say. What do you think? Alrighty. So let's have a look at uploading a screenshot of our MCP configuration while we wait for that answer to load up. Okay, our cursor settings, let's take a screenshot of it. Isn't it cool? We just got MCP servers like set up in cursor just like that. Oh, which one do you like more? I think I might like this screenshot even more. So I'm gonna use this screenshot today. Let's go ahead and take a screenshot of this one. And let's submit that. All right. Very nice. So is UV similar to Node.js? While both UV and Node.js are tools used in software, they serve different purposes. Node.js is a JavaScript runtime environment, and UV is a Python package manager. So they are essential tools in their respective ecosystems, Node.js for JavaScript and UV for Python, but they are not interchangeable. Okay, they work for different programming languages and they have distinct core functionalities. Okay, cool. So thank you for the lovely question, and I hope that helps you understand that Node.js is for JavaScript, a completely different programming language, and its purpose is to help you run JavaScript code outside of a web browser. Whereas UV is for a Python environment, and it is actually for installing and managing Python software packages. So they do very, very different jobs. And great addition from I'll never be tired of saying this name. UV is not just a package manager, it's also a project manager. It reads the TOML file. Oh, that's a great learning. So there is a difference between a package manager and a project manager. A project manager just makes sure that, for example, your environment or your project can be running. And a package manager is responsible for just installing the tools. Pingo Pango says classic turn it off and on again, because do somehow even got the Postgres one working just by opening cursor again. That's so curious. And that's actually happened to me quite a few times. Somehow just by opening cursor again, the MCP server works. Awesome. I think we're ready to move on. Okay, you can see it's all green. It looks good. So in this next tip, let's actually put these servers to work. We're gonna build our database with AI assistance. We're gonna be creating that working PostgreSQL database now. It's gonna have like 40,000 rows, which sounds pretty fancy, but really it's gonna be as simple as running a command to load some data that comes from a file. So it's actually gonna be simple, even though it visually looks pretty cool. We'll use the Docker MCP to spin up a PostgreSQL container. Whoa. So this container is going to be a package that contains the database and all of its dependencies. It's going to let you run PostgreSQL consistently across different environments, so you don't have to worry about environment setup. Love it. Okay, and then we've got our Postgres MCP. Yeah, it is the server that helps LLMs securely interact with the PostgreSQL database. So it's a two-step thing. first MCP, Docker MCP, is for actually creating that database, PostgreSQL. And then the Postgres MCP is to actually set up the database schema and actually make sure that we can analyze the data that's in that database. So they do slightly different things, and that's why we need both. All right. So in this step, get ready to prompt cursor to create that container, and then we're going to prompt cursor to configure something called database users. Here you go. You can even ask now if you're curious, what are database users? You can load demo data into the demo database, and then we're going to visualize it. And here is like a little diagram if you like to see a little flow chart of exactly what order we're going to do everything here. All right. So if you've done an AWS project with NextWork before, you'll remember that we always require that you use an IAM admin user because that is security best practice, all right? And creating a database user is a very, very similar concept. Just like you have a username or password to log into your computer, a database actually needs different users to control who can have access to do what in the database. So defining a user with specific credentials and giving it permissions to do specific things is great to make sure that your data is protected from unauthorized access. All right, so in this step, we're going to be using the Docker MCP to spin up a PostgreSQL container, i.e. a package that contains not both, but actually it just contains a PostgreSQL database and all the dependencies required to run it. And then we're going to use the PostgreSQL MCP to analyze the data in our database. Well done. So, like we mentioned before, MCPs make life very, very easy for us because instead of us manually running the commands to create that container, let's actually learn how to just instruct cursor to do it for us. So we're going to tell cursor, and you can open a new cursor chat by clicking on the AI pane button on the top right. So you can either click on that, or you can do Command L on your keyboard. You can also do Command Option B. Is that right? Yeah, there you go. It comes out like that. Okay, make sure your chat is in agent mode. Don't use ask mode, okay? If you're using on ask mode or plan mode, it can't actually make MCP tool calls. So in agent mode, let's ask using a Docker MCP, create a PostgreSQL container named PG local on a specific port. It should have a username and password of app, and the database name should be called demo. So let's run that now. Oh, and I've hit my limit, so I'm gonna just switch my model to auto, so I'm not always using the same model. My goodness. So we're creating a PostgreSQL 16 container named PG local on the port 5432. All right, so just now it's I just stumbled on my own words. It's just made an MCP tool call called create-container. So this is a tool call that you can actually find out about. So you see how it says create-container. So it's made that tool call to our Docker MCP. Oh, interesting. And it looks like we've got an error here. Let's resolve it together. Let's see what's going on. Client error for the command, unexpected non-white space character after JSON at line 1. Is Docker running? It sure is, isn't it? Docker is running. Oh, it actually ran the create container command, even though it says Docker error show output. What's going on? Can we even list our containers? Oh, successful call to list containers. Hey, we've actually created our container even though it says Docker error. That's curious. Let's have a look at what's going on in Docker as well. And then so we can better understand this error. Well, we have seen a success state, and we can even double check, in Docker desktop, is there a container running? Oh, there is one, and it actually started 48 seconds ago. Interesting. So we have successfully spun up a container, even though we've run into an error. Curious. So curious what's going on. All right then. What we can do though is we can. Oh, thank you so much, Subham. You have to work, but thanks for the guidance. I will listen to the recording. Have fun at work. All the best. Hope you have a great day, Subham. Thanks for joining. Then see you next time. Let us take a screenshot of this so we've got something to share in our documentation. So we've got a container running. Great. And to be honest, Docker MCP, it doesn't seem like it can connect. So what's going on? Is this the kind of error that Deuce you were seeing too previously? Make sure Docker desktop is running. Make sure Docker is accessible. Yes, it is. I have to say, this has definitely, I've had my ups and downs with this myself before, where it says it's not running, but actually it is. So if the MCP still can't connect, we can create the container manually if we'd like, but the container is already created, so we don't need to do that one more time. What happens if I close and restart cursor? Let's open up MCP data series again, and let's check our tools in MCP servers. Oh, maybe it needs to access data from other apps. Maybe not. I'm curious. But again, it seems like the error doesn't actually exist. It could be a bit of a ghost error. So like Deuce, all I had to do was quit cursor, open it again, and it's working now. Awesome. Next up, now that we've got our container and it's already got our PostgreSQL database running in there, it's called demo. Next thing we've got to do is just create that application user. So again, the application user has limited privileges, or regardless, just having a user that's separated from your super user called Postgres, which is a default user that gets created with all databases, is a great idea for security, making sure that an attacker would only have access to limited privileges that you've given to the application user, not full access that only a super user would have. Okay, so let's have a look at whether we can create that user now in our database. So this time we're really testing the Postgres MCP now. The Docker MCP clearly worked. It created that container for us. Next up, Postgres MCP. Let's create a database user called app. With the password app, we're going to grant it permissions on the demo database, and then we're going to create a schema called app that's also owned by this user. Very interesting, yeah. Stu says, I also got an error from the MCP on output. Oh, no way. What was the error that that was in your output? Even though it created the container and it was built correctly, right? What's going on here? So you might be wondering, what is a schema? Okay, so what's a schema and what does it mean in a database? So a database is a top level container that holds all of your data, whereas a schema is called a namespace inside that database that organizes tables into logical groups. So it's like folders in your computer. A database is a huge thing. It really just contains everything. It's like your hard drive. Whereas schemas are like namespaces, so it just organizes different folders and tables within that database, groups them together. So this lets you separate different parts of your application. You can have an app schema for application tables, reporting schema for analytics tables, and you wouldn't need to separate them into completely different databases. All right, so as you might notice, some of these commands have already gone ahead and just run without me needing to select run, and that's because I do have a few things that are automatically configured to just run automatically on cursor. But there's a few things that I still need to manually allow. And it's always a good idea to have a few things that you say, hey, like, I really have to manually allow this. Things like deleting something is a great one, for example. Like, I really have to manually allow it when you want to delete an entire folder. Okay, so the setup is now complete. There's a user now. They've got permissions to the database. There's a schema called app that's owned by the user. And I'll just zoom in a little bit more so you can read this easily. And the user has full permissions on the demo database and the schema. Perfect. I think we've set up our database user correctly. And if you run into any errors, you can always check these out as well. So your database is now configured with proper users and schemas. Let's move on to loading the demo data. All right. And we'll do a quick reflection as well on why we created an application user. Okay, we created an application user called app. Every PostgreSQL database comes with a default super user called Postgres, which has access to everything in the database. The difference between a super user and an application user is, what is it? Is that an application user can have limited privileges, i.e. permissions to do certain actions in the database. It is a security best practice to use a database user because it lowers the risk of what attackers could do if they gain access to our database. If they can access the database via the database user, if they can access the database via the database user, they are way less likely to be able to do harmful actions like deleting an entire table. Okay, cool. Now for the fun part, we're going to fill this database with real data. We've prepared an SQL file packed with realistic e-commerce data, customers, products, orders, and more. So there are over 40,000 rows ready to go. All you got to do is click on this to download it, download the file, and save it into your project folder. Okay, so from your I've clicked on that link to download the file, and now just drag that from downloads straight into the project folder that's called MCP-data-series. Nice. Inside, you've got lots of tables and data. You can read this to better understand it, get a preview, but we're going to visualize it very soon, and we're going to use that visualization instead. Simply run a command to load that demo data into your database. So we've got the Mac commands and the Windows ones. And we'll run the Mac one into that integrated terminal. And just like that, we've already loaded all of that data. Cool. And look at this. This is the amount of data that's going in that belongs in that file. And you saw how quickly we just loaded all of that into our PostgreSQL database. So that's pretty impressive. Nice. So what do you see in your cursor chat? Oh, that is a typo. Not your cursor chat, but your terminal actually. So do you see data loaded successfully? That was for us. But if you've got a file not found error, here are a few things that you can do to troubleshoot. I'll just leave that on for a few seconds if you'd like to have a look. So make sure that you have saved your SQL file of all that demo data into the same folder as where you're running your terminal commands. Okay, if you run pwd, can you just make sure that where you're at is in the exact same folder as all of your project files? Yeah. Okay, does this match up? Make sure your file name is named exactly demo data SQL, because we do reference it by name in our command. Okay, and there are a few other tips in SQL execution errors if you see an error while it's loading too. Okay, so how do we load that demo data? We loaded demo data by downloading a demo data SQL file. And the demo data SQL file contains 40,000 rows of data, and it's all e-commerce related data though, too. For example, tables for customers, products, orders as well. And Mizuchi says, good luck to you. Thank you so much, Mizuchi. Very good to see you here. All right, let's select done and keep on going. All right, so we're already up to verifying that our setup is working. So to verify that our setup is working, you know how we could run docker -- version to check if Docker is installed. In this case, let's actually use our MCPs to go in and just double check, hey, what containers are running? Is our PostgreSQL container running? Okay, if it is, then using the Postgres MCP, can you tell me what are all of the tables in the database? Look, if our setup isn't working, then we'd be running into errors, or we'd be hearing from Cursor that it has no idea, you know, what our containers or what our tables are. So let's see if this works. Okay. Okay, this is what we should expect. Cursor should come back with some information about running Docker containers, so that they do exist and they're running too. and also PostgreSQL connection details, like what are the tables in your database. Okay. Oh, luckily it seems to be connecting to our Docker MCP fine, so it can run that list containers tool call to ask, Docker MCP, like, hey, can you tell me what are the containers that are running locally? Okay, cool. Since Cursor should be able to tell us about our setup correctly, we can take a quick peek at the data next. Okay, there you go. Look at this. Perfect. So there is a description of our Docker containers. It's called PG local. That is the name of our Docker container. It's running. Nice. And here are the 4 tables in our demo database. Nice, just like what the project guide says. So it seems that we've got the tables are in the app schema, and everything looks exactly as we've set up. So that is some great news. We can now try to visualize all of this by running this next prompt. Using the Postgres MCP, let's read the database schema and sample 3 rows from each table. Create a mermaid diagram including the example values, and render the diagram in the chat only with no files generated. Use a high contrast style so we can actually read all of the words in that diagram. Cool. If it's successful, you should be able to see your mermaid diagram pop up in the chat. It might look something like this. The formatting could look slightly different, and that's totally fine. But if something's not working, you can always troubleshoot here too. All right, let's run those tool calls, hey? Oh wow, okay, now it's sampling 3 rows from each of our tables. Good. Oof, off it goes. Nice. So look at that, it's run some SQL commands to select 3 items from all of these tables. And now it's creating a high contrast mermaid ER diagram with example values. Well, what is a mermaid ER diagram? So an ER diagram stands for Entity Relationship Diagram, and it is a visual representation of your database's structure. It shows tables as boxes, columns inside each box, and arrows connecting those tables to show their relationships. So the diagram in this case, we've also specifically asked, can you display some sample data so you can see real values in our database? Very nice. Yo, look at this. It looks like we've got our entity relationship diagram all set up. It looks pretty good to me. And what a nice and visual way to see the 4 tables that now exist in our database. Let's have a look and expand that here. Here we go. We've got customers, orders, products, and order items. Love that you can also see the relationships just like this. Customers place orders, and then order item, okay, contains orders. And then there's also an included in thing for products. Yeah. So the products are also included in or referenced in the order items. Very cool. Very, very cool. Let's take a screenshot of this created diagram and let's add that to our documentation. So let's go ahead and add that in here. Cool. And let's respond to this question too. So we verified our database. Whoa. We verified our database by asking Cursor to use the Docker and Postgres MCPs to summarize our current setup. Oh, this is so sweet. A big shout out to Maya here with the amazing support, and Maximus saying love mermaid diagrams. Ah, that's so sweet. Yeah, we love a mermaid diagram. It's such a nice way to actually visualize things like relationships, and I feel like databases can feel very intangible. You know, another intangible thing would be probably cloud networks. So it always helps when there are diagrams to help us make it feel a lot more tangible, or like something with a physical presence. Okay. Okay. So the mermaid ER diagram, and we can even be clear and say it's an entity relationship diagram, shows tables as boxes, and it says columns inside each box. Columns as columns inside each box, and relationships as arrows. For example, the diagram shows that products are connected to, ooh, can you tell? Products are connected to order items, okay? Because they're connected here. Nice. So let's submit that, and well done. That is the main project completed. You have learned how to use MCPs and Cursor to create your own Postgres database and also load data so that you can have a preview or visualize a little bit of that database. Now you might be thinking, oh my gosh, there's so much I can do here. I've just learned how to set up a database. Now what? Like, what's next? So what's next is we do have 3 more projects in this MCP and data engineering series. We're going to learn how to actually really analyze our data and get customer insights using dbt. We're going to be learning how to perform things like queries and have some sort of playground setup for queries using Jupyter MCP, and then really get advanced with visualizations using Grafana MCP. So there's a lot more coming up in this series, but in the meantime, if you've got a spare maybe 10 minutes, why don't we do a secret mission together so that we can actually optimize the performance of our database? Okay, you're thinking, what do you mean by optimizing a database's performance? What does performance even mean in a database? So just like how, when you look at an athlete, you can say, okay, their performance is like how fast they're running, or maybe I would say an athlete is also like how consistently they're running, like their performance. A database is actually very similar. Database engineers or data engineers care a lot about how their data is stored and how the database is structured, because that can have a huge impact on how efficient it is at running queries. And query time, how long it takes to load a query, can actually really speed up an entire organization, because you can get insights in real time, or maybe your team is unlocked to actually find all kinds of insights simply because of the way you've structured your database. So this secret mission is all about using the Postgres MCP to perform something called a database performance audit. This audit is going to help us point out whether queries are fast or slow. It will also implement something called index optimizations, which is basically something that will help structure your data in a way that will speed up the querying of it. So I hope you enjoy this secret mission. It is so valuable to learn performance optimization. And check out this GIF as well. Nice. So let us unlock the secret mission now. And Deuce, thank you so much for the sweet message. Very entertaining. That's cool. Okay, so for our secret mission, we're going to perform a database performance audit which looks at query load time. It also looks at what else does a performance audit do? Here you go. It identifies slow queries that need optimization, missing indexes that slow down searches, database health issues, and bottlenecks and inefficiencies. Okay, so we can look for missing indexes, and we'll also learn more about what indexes are in a second. Database, health issues, and bottlenecks and inefficiencies. Database administrators care about this because slow queries in production can really cost the company time, money, and their advantage. i.e., being able to uncover insights about your customers and have a team that operates quickly can give a company a huge advantage over its competitors. So this optimization helps by, this optimization, I feel like this introduction hasn't given us enough clues on actually saying how this optimization helps. But a clue is that I'll share with you now is that we'll be reorganizing our data so that queries can find the right data even faster. Okay, so if we're querying or searching for, how many customers have ordered this product, we're going to be optimizing our database and changing a little bit of the way it stores things so that it can return those results even faster. Okay, so in the cursor chat, we're about to send this prompt that uses the PostgreSQL MCP to audit our database. Why don't we run this query or prompt first, and then we can break it down while it's running in the background. Okay, so let's create a new chat and run that prompt. All right, so audit my database. Here's my scheme, audit the app schema, which has the customers table, orders, order items, and products. Okay, let's run that. Run these checks. Let's check, explain, analyze on a joint query between orders and customers. Show the execution time, show the scan type. Run a check on missing indexes. Check which tables lack indexes on foreign keys. Interesting. Cache hit rate. Query something called a pgstat database. Present those findings in a table with those columns, issue the impact and priority. And then provide top 3 optimization recommendations with exact SQL for us to implement these recommendations. Keep your responses concise, but do include some key metrics so that we understand the impact. Okay. So I think we're starting to understand that we're basically asking Cursor to use the PostgreSQL MCP to analyze the performance of our database in 3 different ways, and then suggest top 3 recommendations for optimizing our database performance and improving it. Okay. So it looks like it is running some checks, and it is actually looking at our entire schemas tables to understand how it's currently structured. But what do indexes actually mean? So here we go. So explain, analyze is used to show how queries execute. We're checking for missing indexes, and here, why don't we just ask directly as well? What does explain, analyze do? Okay, so explain, analyze was up here. Run these checks, explain, analyze. What does it mean to run, explain, analyze on a join query? What are indexes? So many questions. What does it mean when an index lacks a foreign key? And next, for the cache hit rate, what is a cache hit rate? What is pgstat database? Ooh, let's find out. Okay, so while we wait for that deeper explanation on our command, here is already the results of all of those different audit strategies. There was 1, explain, analyze, 2, looking for missing indexes, and then 3, understanding the cache hit rate. And then there's already a finding summary on things that it's found. And looks like there are some missing indexes, okay? And then it says the hash join with sequential scans. Current join uses full table scans. All right, so it's now gotten an understanding of how our database is structured, and it's saying that it is a high priority that we're missing indexes. So that's why its top 3 optimization recommendations are all about adding an index in different kinds of tables. Okay, good to know. Now, in the meantime, let's actually break down this query. Okay, what is the actual optimization that we're trying to do? If you're ever, wondering, oh, but what is this? Like, what is actually going on? Don't hesitate to add all those questions into your chat so you can understand your project even more. Okay, cool. So we've got explain, analyze, which is a powerful command that helps you understand how your queries are executed and identify performance bottlenecks. So when you run explain, analyze before a query, PostgreSQL doesn't just show you the planned execution strategy, it actually runs the query and collects real-time statistics about its execution. So when we say we ran explain, analyze on a join query, we're basically running a join query, and then we're asking PostgreSQL, hey, while you run this query, can you please show me your execution strategy, how you're running this query, and also real-time statistics about the actual time taken, the number of rows processed, whether indexes were used. Nice, that does tell us quite a lot, doesn't it? And joins, which is basically to add 2 tables together, is known to be very resource intensive. So being able to run explain, analyze on a join query definitely exposes 3 things. The join method, what was the method used to join those tables together? The scan method for each table involved. How did Postgres actually access the data? Sequential scan, where the system is actually reading every single row in the table from beginning to end to find the data it needs? Or is it an index scan, which is a much smarter way that lets the system actually find and retrieve specific rows? Like it's using Command F without you having to like read down the table. And then a bitmap heat scan as well. Okay. So that helps us a little bit to understand that first check, explain, analyze, and then there's also an explanation for indexes, which are special lookup tables that the database search engine can use to speed up data retrieval. Think of an index kind of like that glossary in the back of a book. Instead of you having to read the entire book to understand a specific topic in the index, you can go straight to the back of the book, look up the word you want to learn. Let's say we just want to learn MCP, and go directly to that page. That's why indexes are so helpful. They actually help the database quickly locate the rows that it's looking for, so it doesn't have to read the entire book. Okay. So a foreign key is basically what links two tables together. And basically, when we say there are no foreign keys, it means that there is no. I just heard a sound. I thought something had happened. No worries. So if a foreign key column lacks an index, it basically means that there isn't like a specific key that helps us with joining two tables together, for example, to help make the query run even faster. In fact, I think that explanation was a little bit complicated. So let's say, explain in simple terms. How are indexes and foreign keys related? Okay. And then you've also got a cache hit rate for that third check. And that one is about indicating how often the database finds the data it needs in its memory cache, which is basically kind of like a buffer that helps us with storing temporary data. And databases often have caches because it's actually faster to access your cache than it is to access the disk, which is like where all the data is saved. It's kind of like how you've got your phone, and your phone, sometimes you can swipe to see what are your most recently accessed apps and just click on it and then go back straight into where you left off in the app. That's like your cache, whereas your disk is kind of like all of the apps. And it certainly takes a lot less time to reopen something that is like saved and is something that is ready for you to reopen in your recently accessed app than it is to boot up an app from scratch if it just lives in your home screen, for example, and you're opening it for the first time in a long time. So a high cache hit rate is what you usually want because it's basically what helps your database actually use its memory to give you data quickly. There you go. A low cache hit rate is a bit of an orange alarm bell because it tells you that your queries aren't accessing data that is frequently cached. Cool. If you wanted to know more about foreign keys and indexes, that middle one, when a foreign key is like a rule that says this piece of information in one table must match a piece of information in another table, an index is like a shortcut or a fast lookup tool. If you often search for customers by their ID, an index on the customer ID column makes that search a lot faster. So while a foreign key creates a link between tables, an index on that foreign key column makes using that link fast. When your database needs to check those links, having an index on the foreign key column means it can find the related information much more quickly, just like how using a book's index helps you jump to the right page a lot faster. So interesting, eh? I think the concept of like how data is structured and how it goes a really long way just shows us that databases is like a science, honestly. I would love to really understand the behind the scenes of how indexes affect like the way data is retrieved. Like, I just wish there's something that you could like watch or see to really see the difference. Cool. So we have got our top 3 optimization recommendations. It's come back saying, hey, you just need to add these 3 indexes. And again, indexes is what helps us with using things like foreign keys even faster. Okay. So once you review Cursor's recommendations, you will see suggestions like you should create these 3 indexes. And the next thing you can tell Cursor is to just create the indexes that it's recommended. So let's copy that prompt. Okay, you've told me I should create 3 indexes. Now, using the Postgres MCP, just create the ones that you recommended in your audit. All right. In the meantime, we're gonna write a little response on what the Cursor's database audit found for us. So, Cursor's audit analyze the performance of our database in 3 ways. By running explain analyze on a join query means we can understand PostgreSQL's execution plan and execution time for the query. Cursor's audit. The audit also found indexes. We'll just continue running those commands. So that's creating the indexes for us. But did it find a bottleneck? I would say maybe it's just the optimization recommendations. Okay. The audit also found bottlenecks in our database organization because we are not using indexes. The recommendations included adding indexes in, there was a specific table that it recommended indexes for order items, which speeds up order detail queries and reduces sequential scans on the largest table. It also enables index-based joins and faster customer order lookups. Okay, cool. So let's add indexes in the order items table, which will have this impact, which enables index-based joins and faster customer order lookups. Awesome. So now that we have created our indexes, there's already a mention about the performance improvement. The query plan now uses indexes. So if we try to do the same query, which is that join between customer orders and our customers, then we're now using a bitmap index scan using that index that we've created. So the improvement is that it's now 52% faster. The execution plan also shows that index scan really replaces the full table scan. Yeah, before we created these indexes, when we ran that query, Postgres needed to actually look at every single row in the database, but now it no longer has to because it can use the index. So you can upload a screenshot of the performance improvement, and you can even run this command to specifically say run explain analyze to show the performance improvement before and after the index. If you'd like, you can also run this command, or if you're happy with that 52% improvement here, you can use that too. Okay, so here, let's say that we implemented the index recommendations for the query that filters orders by customer ID. After creating the index, performance improved by X%. Note results vary by environment, and the execution plan changed from sequential scan to bitmap heat scan. Which means Postgres no longer needs to look at every single row sequentially to query the database. Oh, to look for data. Cool. These writes, it's great how it executes every query correctly. Yeah, I think that's the thing with MCPs. You know, the more specific your requests, the better it is at executing every query and doing exactly, what you want it to do. It's also the underlying theme for so many uses of AI and LLMs. Like the clearer you are, the more successful it's going to be. Okay, really great to see that we've got a 96.1% improvement. Before we were using sequential scans, which means looking at every single row of the database. And I don't think we have a simple explanation of bitmap index scan yet. So let's say write a simple explanation of bitmap index scan, 3 to 4 sentences, and how it's different from a sequential scan. Okay, very nice. And we can say performance improved by 96%. Awesome. And we can take a screenshot of that improvement here. Excellent. Okay, so bitmap index scan versus sequential scan. Bitmap index scan uses an index to find matching row locations, and it builds a bitmap of those pages and reads only those pages. No need to read an entire table. The index already tells Postgres exactly which rows to even focus on. Whereas sequential scan reads every row from start to finish, checking each row against the filter condition. Cool. This makes bitmap index scan much faster for selective queries, especially when you're looking at large tables. I mean, we're looking at something with 40,000 rows, but imagine actual production. Imagine databases that are actually in production today, which have millions or billions of rows of data. Like, how big of a difference would that, would using bitmap heat index be? My goodness. This is really great, says Deuce, for improving request performance. I didn't know that was possible. This information is worth its weight in gold. That's such a cool way to say it. And really, yeah, this kind of stuff takes a little bit longer to understand, but it's so worth it. You end up learning a skill that actually helps you improve pretty much every single database that is currently using sequential scan. Now it's always in my mind, are we using indexes? Are we using index scans instead of sequential scans? So here are some extra challenges if you'd like to do a little bit of bonus work. But in general, you've actually completed the secret mission. You've already improved performance by 96%. That's something to be incredibly proud of, and well done. Okay. So before you go, you can always clean up your resources. So here is a list of resources to delete, and we've also got the step-by-step guidance on how to delete those resources in the step-by-step guidance track of this project. The good thing about everything that we've done today is that everything is free. So if you'd like to also keep your resources in advance of the second project that's going to come out later this week, highly recommend that you can also just keep your resources as well. Nice. So what were the key tools and concepts we learned in this project? The key tools we used include MCP servers. We used Postgres and Docker, and also Cursor itself. Key concepts we learned, oh my gosh, so much. We learned MCP setup. We learned how you can use Docker to run a Postgres database. We also learned about performance optimization. And is there anything else we learned? On my mind, I think we also actually learned about our dependencies. We learned about the importance of environment setup like UV, Python, especially UV and Python being required for us to run our MCP servers. This project took us approximately 2 hours, including live demo time. The most challenging part definitely was, I'd say the most challenging part will be this secret mission. Performance optimization is definitely a level up in terms of complexity. It was most rewarding to verify everything we've built. You know, it was very satisfying to see the Docker container being created. It was also very satisfying to preview the data in our tables, you know, being able to like actually see like, oh, this is the table that we've like loaded. Visual diagrams that represent our database. With the skills we learned, I want to build, this is cool. I want to build a database of all the project requests that people have for next work. Which I can then query via my cursor chat. How handy would that be when we're writing our next project? So thank you so much for doing today's project. Why did you do the project today? Did this project meet your goals? So we did this project today to learn foundational data skills with the help of AI. Shout out MCPs. Another database skills I want to learn is, are there any requests in the chat? Anything people want to learn? Maybe you might want to learn advanced data visualization. Or maybe you want to learn like how to query data or how to actually make the most of your data and how to query data, i.e. understand the full use or like the full potential of the data that we've got. You know, because it's one thing to have data, it's another thing to know what to ask from that data, like what's in your database, to get more insights or to understand something that you might not be able to explain. It is really, really cool when someone is able to say, oh, look at this pattern that's happening in this database. And I'm like, I did not notice that. I have no idea how you noticed that. So I would love to almost have that third eye in data. Okay, so mission accomplished. Well done, everyone. That's a wrap, and you've did it. So you've built a complete Postgres database that you can control using natural language and Cursor. We've learned how MCP connects code editors like Cursor to external tools. We've learned Docker fundamentals. You know, we've got containers, and then in that container, we are running Postgres with all of the dependencies that are already inside this isolated environment, so we don't need to worry about environment setup. Also, some PostgreSQL basics like users, schemas, tables, and indexes. Yeah, this is especially for everyone doing the secret mission. Then we've got database performance, which is query plans, execution analysis, and optimization. Great. Again, this is a big shout out to everyone that does the secret mission. And how to manage infrastructure by just typing what you want. Exactly. I think that was the key theme for this entire project. You could actually do all of these actions just with natural language prompts without needing experience in SQL or without needing experience in Docker. So, are you ready to quiz yourself again? Let's take the quiz and see whether or not you've learned something new or maybe something that you have a different perspective on from this project. What is the main function of MCP in this project? Is it to manage operating system updates? Is it to replace Cursor's chat? To allow Cursor to interact with external tools? Or to directly install Docker Desktop? I've exposed myself with my Cursor, haven't I? And what file is used to configure MCP servers in Cursor? Is it MCP JSON? Is it Docker Compose YAML? Is it the pyproject.toml file? And lastly, is it the settings.json file? This one is tempting, isn't it? It looks very, very close. But I think MCP still has the biggest giveaway. And there we go. MCP JSON is the file where MCP servers are configured in Cursor. Next up, what is the purpose of UV in this project? So UV is that Python package manager, and we used it so that we can run MCP servers in this project. So what is a prerequisite for running Docker Desktop on Windows? Again, such a harsh question knowing that we actually ran this entire project on Mac today. But the answer is WSL2. You are going to need that to run Linux containers. And what is the primary purpose of using Docker? Well, we have said this a few times, so I hope you know this answer. What do you think? Is it A, to manage your Cursor settings, B, to run Postgres in an isolated environment, C, to manage Python packages, or D, to directly edit your SQL queries? Why do we use Docker in this project? So it is to run Postgres in an isolated environment. Very nice. So we've got a 5 out of 5 team. Nice work. Coming up next is Project 2 of the Data Engineering and MCP series. Get ready to transform your raw data into customer analytics with the next MCP, which is called DBT, the Data Build Tool. Make sure to join the Nextweek community as well, so you're one of the first to hear it when it's out. Hopefully we can release this at the end of the week, but of course, the Next community is the place to stay up to date on everything Nextweek. I'm also just going to chuck the link to join the community in the chat so that you can join straight away if you're tuning in from YouTube. Here you go. Hope to see you in the community, everyone. In the meantime, let's click Mission Accomplished. We have completed this project, and it is time for us to have a big hurrah and check out our documentation. So it is getting saved to my portfolio right now. I'm just gonna wait another minute. And you can actually generate a social post just by clicking on one of these buttons here. You can visit LinkedIn and create a new post so that you can check out this post that we've written as well that you can use as inspiration. So Postgres is the fourth most popular database globally, powering companies like Instagram, Spotify, and Uber. But most developers still manage it with SQL commands and complex syntax. So I just set up a Postgres database and managed Docker containers all through natural language in Cursor. No SQL, no Docker commands. Check out my documentation for the step-by-step process. And here's a teaser of the process. Is there anyone else using MCPs for database work? Huge thanks to Nextwork for this awesome project guide. Oh, nice. All right, I think the project should be saved in my portfolio now. So let's check it out. It's right here in my portfolio. Cool. All right, introducing today's project. We're going to build a Postgres database using Cursor. Here are the key tools and concepts, the challenges and wins. That's right, every single thing here was a response in the project as we were going through every single task and submitting all of those text responses. It's very nice to see it all come together in a beautiful document. And it just, like, you're like, wow, did that in 2 hours? Give yourself a pat on the back. Look at all of these learnings and evidence of what you've just learned as well. Incredible. I'd say that was a very productive 2 hours, everyone. Thanks so much for spending that with me. And also, hot tip, don't forget that you can actually attach your documentation as a PDF that you attach to your LinkedIn post. Okay, so you can stick that into your LinkedIn post when it's done downloading. Might as well show you how it works while we're here. Add a document, choose your file. Okay, it's not downloaded yet. That's okay. All right, it's downloaded now. We'll choose your file. And here. And let's say Postgres MCP AI meets SQL. Oops. And then once it's done loading, you can click done, and that attaches your documentation to your post too. So well done, everyone. I can't wait to see you in the next project when we are using dbt MCP to turn a lot more of that data into customer analysis and insights. Hey, oh, look at that. Looking good, everyone. We're doing good. Whoa, so cool. I can't wait to see everyone's posts, by the way. Don't forget to tag Nextwork, yeah? And see you in the community. All right, bye everyone. Hope you have a lovely rest of your day, and a big shout out to everyone that tuned in live. See ya.